Hey guys, today we'll be talking about different kind of force that you will see in your course, and in the IGCSE level it would not be dealt with in detail, but still it is a very important force, and this force is known as centripetal force. The centripetal force exists between objects or in objects that are moving in a circle. Or moving in an arc of a circle. Now let's talk about the first case. Let's see what this means. Whenever, let's say this is the object and this is its path, its trajectory. Whenever, okay, this is not a perfect circle, but this is what I mean. Whenever an object moves in a circle like this, there exists a force which is known as the centripetal force. The centripetal force is simply denoted by F and subscript C, shows centripetal force. It has the same formula, which is Fc is equals to ma, or Fnet is equals to ma. So whenever an object is moving in a circle, there exists a centripetal force. That is all you know right now. Or whenever an object moves in an arc of a circle, like let's say this is the object and it moves somewhat like this. From here, it will go here, then come back here, then here. This is an arc of a circle. There exists a centripetal force. Now, what is the centripetal force? Let's talk about that. Basically, a centripetal force is any force that manifests itself and keeps the object moving in a circle. It could be any force. So any force manifesting itself or changing itself to keep the object moving in a circle. Now what happens, let's say let's take an example here. This is a car here, and this is it's turning around a roundabout. That's it. This is here. It's turning around a roundabout here. Now what happens, that as it's turning, it needs a force to turn in this circle, in this circular thing. In this stage comes out the centripetal force. And centripetal force always acts towards the center of the circle. It always acts towards the center of the circle. Whenever there is an object moving in a circle, centripetal force acts in the center of the circle. Now, how is this centripetal force coming? Where is it coming from? Basically, in this case, in the case of a car turning around a roundabout, the friction force between the road and the tires this changes itself. And forms the centripetal force in this case. This changes itself, the friction force between the tires and the road, and it forms the centripetal force in this case. And centripetal force, whenever an object is moving in a circle, there might be a lot of forces here and there. Let's say this is a force of the road on the tires, or let's say this is the weight of the car right here, or something like this. There might be a lot of forces acting on this. This is the air resistance, let's say. But the resultant of these forces would always have to be towards the center. And this centripetal force is the resultant of all of these forces. It will always be towards the center, and it will always be a resultant. When you are talking about centripetal force, then that is the resultant or the net force acting on this object, and there won't be any other force because that is the net force acting on this object. So basically friction is the one thing that is creating a force towards the center, and you can see that with that force is overcoming all the other forces, and that becomes the centripetal force in this case. Let's talk about another case. Let's take an example here. Let's talk about a pendulum. And this moves like this, and it goes here, it comes back, and then goes here and comes back, and something like this. It moves in an arc of a circle. Now what happens, since it's moving in an arc of a circle, again we know that there has to be a centripetal force acting on this object. Now the centripetal force, this is a rule, it's a thumb rule. Whenever an object is moving in an arc of a circle or a circle, the centripetal force always acts towards the center of the circle, somewhere here. Let's say if this is the center, then this is the force, this is the net force. The net force equals the centripetal force. But in this case, can you think what is the thing that is creating the centripetal force? Because there is no friction like there was earlier between the tires or something. There is no friction here, but there is a tension in the spring, and in this case the tension in the string changes to centripetal force. In this case, the tension is the thing that changes and forms centripetal force. Now, and it will always be towards the center of the object. So let's talk about another example. You might not come across this one, but this is a very useful one. Let's see, this is the earth, let's say. This is the earth, and as you know, these are the... Okay, it's taking a lot of time here. So let's see, these are the patches here, and this is your, as you know, 70% of the earth, about 60% of the earth is water. So this is your water here, and here you have it. Alright, and this is your sun here. Let's say right here. Right, this is your sun right here. Now the path that the earth would be following would be something like this. Something like this, and around this, and it will come back here. So it will be moving like this, and then yes, it will have a path. It will be, let's say it will be orbiting the sun, or it will be moving around the sun. So there has to be something that is keeping it in a circle. And from our definition earlier, we know that to move something, for an object to move in a circle, there has to be a centripetal force, and obviously this centripetal force will again be acting towards the center of the circle. Now the question is, what is creating the centripetal force? In this case, it is the gravitational forces between the two of them, the two objects, that manifests itself to form the centripetal force. So there was earlier there was a gravitational force. Let's say something like this. There was a gravitational pull, something like this, in this direction, and this changed itself and formed a centripetal force, allowing it to move around this orbit like this. So in this case, it is the gravitational force that is creating the centripetal force and allowing it to move. So you can always see that there is something that changes itself and forms the centripetal force or allows the object to move around in a circle. Now, if I ask you what is the direction of the acceleration, what is the direction of acceleration? I might get a lot of answers here, but I want to clear one of your concepts here as well. Always remember that the centripetal force is a net force. So in this case, the net force, let's say when the Earth is here, the centripetal force will be in this direction. This is the centripetal force. When the Earth is here, the centripetal force will be in this direction. So we know from our previous concepts, the direction of acceleration is always in the direction of the net force. Direction of the net force of F net. And here, the centripetal force is the net force. So the direction of acceleration will also be towards the center in each of the cases. Here, this is the direction of acceleration. If it was here, then it would be always in the direction of the net force. Now let's take another example here, and we'll talk about all the things that we've learned here, and we'll also introduce something new. Let's say this is an object here, and I am rotating it to make a full circle, and then it comes down, moves like this here, then it comes down. So there are different positions of this object. Let's say at one point it's here like this, at one point it's here like this, and at one point it's inverted and it's here like this. Now these are the four. Let's say this is 1, this is 2, this is 3, and this is 4. These are the 4 places of the 4 positions, general positions of the object. This is the object. Alright, so let's see. Let's talk about the direction of the centripetal force here. We always know that the centripetal force is acting towards the center. So in this case, this is the direction of the centripetal force. Let's talk about our second thing, which is acceleration. The acceleration is in the direction of the force, and so the acceleration would also be towards the center of the circle. This is the center of the circle, and it will be towards the center of the circle. However, let's talk about the velocity. The velocity of the object would always be tangent to the path of motion. In this case, since it's moving here, this is the direction of the velocity of the object. Always tangent to the path of the object. Let's talk about this. The centripetal force in this case, towards the center. The acceleration in this case, towards the center. The velocity in this case, tangent to the path of the object. Let's see, in this case, acceleration here, center, centripetal force, center, velocity in this direction. So always remember that velocity is tangent to the path of orbit, let's say, or the axis of orbit. So always remember that acceleration and net force will always be towards the center, while the velocity is always tangent to the path of the orbit. For your course, this is as much detail as is required. But in the upcoming lectures, we'll be talking about, for A-levels, we'll be talking more about how these questions are solved numerically and how we find out centripetal force quantitatively. So I think that is enough for IGCSE, and if there are any problems, just let me know. Thanks for watching, guys.